Welcome to True Projects. In this video, we are going to explain about the project, which is automated classification of societal sentiments on Twitter with machine learning. Introduction. In the modern information age, social media platforms, particularly Twitter, have become hubs of real-time information and public sentiment. Understanding the sentiments of society during major events is crucial for various purposes, including public health monitoring, crisis management, and gauging public opinion. The project is centered around automating the analysis of sentiments conveyed on Twitter, a widely used microblogging platform, specifically during major societal occurrences. The project utilizes a variety of technologies including natural language processing, machine learning, and deep learning. The project employs a novel hybrid framework that combines lexicon-based sentiment analysis with supervised machine learning techniques for tweets classification. This approach leverages both predefined sentiment lexicons and the power of machine learning models to improve the accuracy. Objective. The project's core aim is to conduct automated sentiment analysis on Twitter during pivotal societal occurrences such as COVID-19 pandemic. The project employs a hybrid framework that combines lexicon-based sentiment analysis for tweet sentiment labeling, supervised machine learning algorithms including logistic regression, random forest, AdaBoost, SGD classifier, k-nearest neighbor, multinomial naive-based support vector machine, multi-layer perceptron gradient boosting, cat boost, and a voting classifier, and also deep learning models like long short-term memory for tweet classification. The project's ultimate goal is to deliver a dependable automated system that is capable of efficiently processing large Twitter data volumes, facilitating real-time monitoring of societal sentiments, precise sentiment analysis for public health monitoring and crisis management, and also offering a valuable resource for researchers, policymakers, and organizations to make informed decisions guided by public sentiment trends. For implementing this project, we need hardware and software requirements. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above are needed. In software requirements, Anaconda 3 and Visual Studio Community version is needed. In the flow of work, we have designed few modules to implement the project. The first one is importing the packages. This module involves importing the necessary libraries and packages of the project. NumPy is for numerical operations, Pandas is imported for data manipulation, TensorFlow for deep learning, Matplotlib and Seaborn for visualization, Scikit-learn for machine learning, and Transformers for natural language processing. Exploring the dataset. This step involves an initial examination and understanding of the dataset that will be used for sentiment analysis. Data processing. In this phase, the data is cleaned, pre-processed, and transformed to ensure that it is suitable for analysis. Visualization using Seaborn and Matplotlib. This module involves creating visual representations of the data using Seaborn and Matplotlib for better insights. Feature selection using formal data. This step involves the formal selection of relevant features from the dataset, ensuring that only the most important attributes are used for the analysis. Lexicon vectorizer. This module employs a lexicon-based vectorization technique to represent text data in numerical format, facilitating sentiment analysis. Splitting the data into train and test. Here the dataset is divided into training and testing subsets to evaluate the performance of machine learning models. Building the model. In this we build various multiple machine learning and deep learning models. The first one is logistic regression. It is used to model the probability of a tweet belonging to a particular sentiment class, making it suitable for binary classification tasks in this project. Random forest. It is employed for its ensemble learning capabilities to enhance classification accuracy by aggregating predictions from multiple decision trees, thus improving sentiment analysis. AdaBoost classifier. It is used to boost the performance of V classifiers, aiding in better sentiment classification by combining multiple models in an adaptive manner. SGD, which is stochastic gradient descent classifier. It is used for efficient and quick training of linear classifiers, making it suitable for large-scale sentiment analysis in this project. KNN, which is k-nearest neighbor. It is used to classify tweets based on the sentiments of the nearest neighbors in the feature space, making it effective for the data points with similar sentiment characteristics. MNB, which is multinomial naive Bayes, it is chosen for its effectiveness in handling text data and its suitability for multinomially distributed features in sentiment analysis tasks. SVM, which is support vector machine. It is used for its ability to find the optimal hyperplane that maximizes the margin between different sentiment classes, making it effective for sentiment classification in high-dimensional space. MLP, which is multi-layer perceptron. It is a type of neural network. It is employed for its capacity to capture complex patterns in the text data, enhancing the project's sentiment analysis capabilities. Gradient boosting. It is utilized to build an ensemble of decision trees, sequentially improving model performance and aiding in accurate sentiment classification. CAD boost, which is categorical boosting. It is an extension of gradient boosting. It is used for enhancing handling of categorical features, improving sentiment analysis performance when dealing with the non-numeric data. Voting classifier. It combines predictions from multiple machine learning models, increasing the overall accuracy and robustness of sentiment analysis. RNN, which is recurrent neural network. It is employed for its sequential data processing capabilities that make suitable for capturing the temporal context in the text data, which is important in sentiment analysis. LSTM, which is long short-term memory. It is a specialized RNN architecture. It is used to model long-range dependencies in the text data, enhancing the project's ability to capture non-sentiments. Convolutional neural network, which is CNN. It is chosen for its effectiveness in capturing long local patterns in the text data, improving the sentiment analysis process, particularly in the case of short text inputs. Coming to the next module, which is training. In this module, we focus on training the machine learning and deep learning models used to prepare the training dataset. Flask framework with SQLite for sign up and sign in. This step involves setting up a web framework using Flask with integrating it with an SQLite database for user registration and login functionality. User gives input. This stage allows users to give input in any language. The given text is translated and preprocessed for prediction. The user input text is translated and preprocessed to prepare it for sentiment prediction. Trained model is used for prediction. The previously trained machine learning or deep learning model is employed to predict sentiment based on the preprocessed input. Final outcome is displayed through frontend. The predicted sentiment outcome is presented to the user through the project's frontend interface. For execution of the project, first we need to open the code folder which contains the source code files. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages that are used in this project, and this typically includes files like index.html, about.html, which represent different pages of the website. And this is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file which contains the algorithm information, and this will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells. This is the sign-up file. This is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So we will copy this path and open the Anaconda prompt. Using the cd command followed by the space, we will paste the copied path and click on enter. By this, the current directory is changed to the code folder's path. Here we need to type python space app.py. This will compile app.py file, and this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we will click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost and the port number, unless configured differently. So this is the localhost and this is the port number. Now we will copy this link provided by the Flask framework and paste it in any web browser. I prefer Google Chrome, so I will paste it in that. So here we will paste the link and then click on enter. So this has redirected to the web page of the project, which is displayed in the browser. And this front end is built by using the Flask framework. Now we will be clicking on the button sign up. And here we need to fill all the registration details if we are registering newly. I have already registered, so I'll directly click on sign in. So here I'll provide my credentials, which are my username and the password. And now I will click on login. So here we can see a text box where we need to enter the message, and for that message we will have the predictions whether the message is positive sentiment or the negative sentiment. So here we will enter the text here. I entered the message here. Now we will click on predict. So based on the given text, it is predicted that the text type is negative. Now we will give one more text and see what will be predicted. I entered the text here. Now we will click on predict. So based on the given text, it is predicted that the text type is negative. Now we will give one more text and see what will be predicted. So I have given another message here. Now we will click on predict. So based on the given text, it is predicted that the text type is positive. In this way, by giving any text, we will get whether the text sentiment is positive or negative. Now we will sign out of the web application. The project has effectively crafted an automated sentiment analysis framework tailored for Twitter. This framework harmoniously integrates lexicon-based methods and supervised machine learning algorithms. Notably, it excels in accurately categorizing tweets into positive and negative sentiments, particularly amid significant societal events like the COVID-19 pandemic. The project exhibits potential for real-time sentiment monitoring during pivotal occurrences. It offers practically utility in domains such as public health surveillance, crisis and management, and the evaluation of public opinion. Collectively, the project makes a valuable contribution to the field of sentiment analysis, aiding informed decision-making by researchers, policymakers, and organizations that rely on insights from public sentiment trends.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.